called when we talk about the entire cell dividing, where the cytoplasm pinches into two. You know what that's called? Cytoplasm pinches into two. Cyto, what do you think? Yeah, cytokinesis. Is that what you're thinking? Yep. Yeah, so it wouldn't be this. So mitosis is where we're just dividing the nucleus into DNA to get ready for cell division. It's so important that we keep the same DNA. We keep a copy of that genetic information. This question, how are mitosis and cytokinesis different? We just kind of talked about that. So we could choose that cytokinesis is involved in the copying of DNA. Cytokinesis occurs at the beginning of mitosis. Cytokinesis is the division of the cytoplasm and cell, while mitosis is the division of the DNA of the nucleus. And then that statement reversed. Cytokinesis is the division of the nucleus in DNA, while mitosis is the division of the cell and cytoplasm. Ashlyn, tell me of those four, which one is the choice that we just talked about? You already know that mitosis is the division of the nucleus in the DNA, because we got that from the first one. Which of these choices states that? This says mitosis is the division of the cell and the cytoplasm. What's this one say? Right? And then it goes on to say that cytokinesis is the division of the cytoplasm. So that's going to be our choice here, number 3, or C, however you want to look at it. Again, it's another question asking you the same thing. You need to know the difference between cytokinesis and mitosis. Cytokinesis, the division of the cytoplasm, and mitosis is the division of the nucleus. All right? How about this one? We're matching the term with its definition. This one was hard because we talked about this. We drew those pictures on the board to try to figure out what these terms meant. And they're all referring to DNA, right? It's just how the DNA looks. So let's start with what I think is probably the easiest one because we talk about it the most. Of those 3 choices, think about chromatin. Chromatin. Thank you. What part of the choices that we have over there stands out to you for chromatin? That's when DNA looks like what? It's like an interphase. It's doing its cell business. How's the DNA looking in there? It's either an identical copy, it's a long continuous strand, like stringy, like thread, or it's short, like it's condensed, so it's big and fat and thick and we can see it. What do you think? Yeah, that's going to be where our DNA looks like the ball of spaghetti, right? We can't do anything with that. We got to like make it a little shorter and thicker so we can handle it a little bit better when we divvy it up during mitosis. So that one's pretty easy. How about chromatid? When we talked about chromatids, this is when our chromosome looks like this, it's short and thick, and we said that this is a chromatid. This little singleton. There's the centromere. Centromere is like a little staple that holds together those 2 parts of the egg. So what would a chromatid be? An identical copy of a chromosome or shortened coiled DNA found during mitosis? Why does the chromosome here look like an X? Because what are these 2 things attached? They're chromatids, but what about them? Are they the same or are they different? They're the same, they're copies. So really a chromatid is going to be an identical copy of a chromosome, and then our chromosome is going to be the way our DNA looks during mitosis. We know it looks like X's with that little centromere, that little staple in the middle that keeps them together. So your answer should look like this. Drag and drop in that. Okay, so seal those in. X out of it. Got it? Then we have this question that asks you to place the 4 pictures of mitosis in the correct order from the start to the end. Think about your gummy worms and how we started off with our gummy worms, right? the first thing that happens is we need the chromosomes to like get shorter and to condense so that we can see them. So which picture just shows the chromosomes kind of hanging out, shorter, condensed? They look like X's now where they've been copied. Say it again, Sandra. B. Here we go. This has got to be like prophase, right? That's when the gummy worms, you made them X's. You've got each chromatid together with a centromere. It's just copies of the DNA. Then what happens in mitosis? That's the P. What's the L? Okay, so Kennedy says C, because what do the chromosomes do? They do what? They line up. They line up in the middle. Then what happens? They're in the middle. What's going to happen to them? They go away. That's the A. Away. Anaphase. So A, that's nice. A for anaphase. They're pulled away from each other. The last part is D. We have, how many nuclei do we have in this picture? We've got 2. We have 1 cell or 2 at this point. Still just 1 because the cytokinesis hasn't happened. It hasn't pinched into 2 yet. So it's 1 big cell with 2 nuclei. That's how we know mitosis is happening. So there we go. That should be our order. Whoops. That should be our order. BCAD. Okay, number 5. Match the images with the correct phase of the cell cycle. Ooh, this brings back your onion cell lab. Let's just go through them in order because I think that'd be easiest. This one's the easiest because it looks like the chromosomes are in the middle. So, Reagan, if the chromosomes are in the middle, what phase does that have to be? Metaphase, middle metaphase, right. Look at B here. Is that one hard to tell what's going on there? Looks hard, right? Like maybe you think it could be prophase or it could be telophase. We're not sure. Let's skip that picture and go on to one that we know might be pretty obvious. Here it looks like the chromosomes are being pulled away from each other. It's got to be anaphase. Anaphase away. What's happening in E? And how do you know that telophase is happening there? Zach, if you had to take a guess, what do you see in E that might be included telophase is happening there? Yeah, you've got 2 what? Cells or nuclei? Nuclei, right? Because in mitosis we're dividing the nuclei, we're not dividing the cell. And then that leaves us with B and D. So we have a choice between the only 2 we got left, interphase and prophase. One of these cells, if you're comparing B and D, one of these cells looks like the nucleus is starting to break up a little bit and things are starting to get shorter and thicker. Which one do you think looks most like that? Aiden, if you had to guess, which one do you think looks most like prophase, where the nucleus is starting to break up a little bit? B or D? Got a 50-50 shot. Think B? Okay? Yeah. Because look at the nucleus. These are usually hard to tell. You can see where the nucleus looks a little bit different from here to here. Here the cell, it has this like dark spot in it that in your lab they refer to as the nucleolus. It's not really a whole lot you can see in here. That's what happens during prophase, is that things start to get shorter and thicker so you can start seeing chromosomes. You don't really see anything too much here, but here I can tell that things are starting to change a little bit, starting to break up. So here's what your answers are going to look like for this one. Get those locked in for yourself. Zach, do you have this CFA pulled up? On another tab. Okay. No, we were talking about the CER. This one we want to fill out again. You gotta. I can only think of one person here that got a 4 on the first time, so there's probably room for improvement for all of us to do it one time. All right, so match the descriptions to each of the 4 phases of mitosis. We got prophase, anaphase, metaphase, and telophase. It's just more of the same. So if we go in order, anaphase, what's the word that belongs with anaphase? A and away. Which of these answers here would you guess, Addie, if you're looking at the possible answers? Describe chromatids moving away from each other like they do in anaphase.
When they separate.
Yeah, when they separate. So like this one, I think you're talking about, chromatids are separate. Right. How about in prophase? This is going to start off mitosis. We know this is the first phase of mitosis. In prophase, we know that the nucleus starts to break down, and we just said things get shorter and thicker. You can start to see individual chromosomes. Which of these choices describes that? Starting to see individual chromosomes, the nucleus is starting to break down. Yeah, we're just looking at which of these possible answers describes prophase. Well, we've got Absolutely. So this choice best describes prophase. Metaphase is easy, because meta, you ought to know meta in the middle, probably till the day you die. But which of these do you think describes chromosomes lining up in the middle, meta middle? If you had to take a guess there, Annika, which one? Yeah. Even if you don't know what the equator of a cell is referring to, you have that word middle there. You should match up and pick that up. And then last is process of elimination. In telophase, the last thing that happens is we now have 2 nuclei that are formed with the exact same genetic information. So here's what your answer should look like here. Oh yeah, there's probably, you need a flat one or a round one? Flat, is this one flat or round here? Oh yeah. If you give me a second, I'll grab you my charger, because it should work with your protocol. Okay, number 7, cells that can specialize. Become many different types of cells through the process of differentiation are called, this is just a term, we said these cells were blank slates. That's how I remember it. This blank slate has an S in it, just like the cell does. Okay, well, tell me, of those 4 choices, which are the cells that can specialize? Also begins with an S. Specialize, blank slate. It's got to be stem cells. They can become anything. Hey, I just read an article, I don't know if it's true or not, because I have to check the source, that in Israel, they successfully regrew in mice spinal cord tissue using stem cells, so that mice who were previously paralyzed were able to walk again. And that's an example of where they're using stem cells and encouraging them with genetics to specialize into the tissue needed for spinal cord. And they were talking about how that's a game changer. Have I validated this claim? No, I have not. I can't remember the source I've read it in, but I'll have to look and see if it's legit.
I think I remember something similar to that, where apparently they're trying to research if with the possible use of stem cells, you can use it to help regrow previous cell in the tissue that would maybe try something.
Yeah.
Using stem cells.
They're doing all kinds of research like that. Remember that we talked about, I think it was in China where they first grew an ear, just an ear by itself. It was kind of weird when it was dead. It's just like a random ear. But yeah, you're right. They were using stem cells to try to see some of the things that they had grown. I don't know enough about stem cells to know in terms of using them for regrowth of things and why they chose an ear. I would guess maybe that, I don't know, maybe it was easier to get those cells to specialize into that particular kind of tissue. Because you have to know, you got to know what kinds of genes to turn on, right? In order to know what to encourage that cell to specialize in. All right, which of the following cells has lost its ability to change and specialize? Which of the following cells has lost its ability to change and specialize? Well, let's use process of elimination. Can a stem cell become any kind of cell? Has it lost its ability to do that? No, so we know it's not this one. A stem cell is exactly the opposite. It can become anything. How about a nerve cell? Okay, that cell is a pretty specific cell. That's one of the cells we said stuck around in G0. Doesn't really go through mitosis or cell division. So, has that lost its ability to change and specialize? Could it still become something else, or is it pretty much done? It's done, because it's a nerve cell, right? A zygote, that's a term that refers to a fertilized egg. Well, a zygote is just a big ball of stem cells that can become anything. So is this an example of something that's lost its ability to change and specialize? No, because it still can become anything. So really, we already know that none of the above is probably not the best answer, because as soon as we talked about a nerve cell, I saw a lot of people nodding their head and saying, yeah, that cell it can't be anything else. So that would be the right answer. That's one cell that's already specialized. So it cannot become anything now. It's already become what it's going to be. Right here we had to determine whether each of the statements are true or false. Stem cells are an example of specialized cells. Is that true or false? Are they specialized cells, or are they cells that could become anything? Yeah, so think again about that, Zach. Are stem cells an example of specialized cells? If they could become anything? They're special or they're not special, I guess, like the one you picked. They don't have a specific job. They could be anything. It's like a blank slate. So when you think about the word specialized, Zach, I would think about specialized as being a cell that has a real particular job, and stem cells don't yet. So I'd say this is probably false. Specialized cells are unique because they each have a different set of genes that have been turned on or off. What do you think about that one? Look at what the answer is. Do specialized cells have different DNA than all your other cells? No, because remember, the whole point of mitosis is to make sure that every single body cell has exactly the same DNA in it, right? The difference between different kinds of body cells are the genes that have been turned on or off. Like we talked about your muscle cell, and let's say a cell in the hair that you have, right? Does a muscle cell need to know about the gene that determines hair color? I hope not. Doesn't. Here, there, right? But a hair on your head might express that kind of gene that determines hair color. So even though both kinds of cells have exactly the same DNA, only some need that gene that expresses hair color. So specialized cells are unique because they each have a different set of genes that have been turned on and off. That's true. Same DNA, but different genes are being activated. Let's look at this statement. Different specialized cells in your body, such as a neuron and a muscle cell, have the same DNA. That's true. We just said that. We just said that every cell is going to have the exact same DNA. Differentiation means that a cell has gained new DNA to change into a different cell. Is that what happens? Do we ever get brand new DNA introduced into any of our cells? We do not, because the whole point of going through mitosis in body cells is to ensure that we all have the same copy of DNA. And then this last one says that specialized cells, such as a neuron or a red blood cell, have special structures that allow them to perform a specific function. Absolutely. If it's a specialized cell, then it has to have something unique about it to help it to do its function. Like we talked even about the shape of red blood cells. Remember, they were like those English muffins and the crust in the middle. They had a dip in the middle. It makes them a little more flexible and allows them to carry a little bit more oxygen. So different cells are going to have special structures that help them to perform a specific function. All right, number 10, which of the following shows the correct sequence of the cell cycle? I'm going to leave it on the answer because in a sense we've already talked about this a little bit when we talked about, well, not really, when we talked about mitosis, we talked about the different phases. But this is from that pie chart that you have in your notes. What are G1, S, and G2 stages of? It's the part where a cell spends like 90% of its life. Carson, do you remember what that is? You have two choices when you think about what that pie chart was divided into, interphase or cell division. What do you think that G1, S, and G2 are parts of? Interphase, because that's where the cell spends most of its life. And then a bunch of people had a question about this. M stands for mitosis, which I don't think we've ever used M to represent mitosis, but some people figured it out, some had to ask. So if I'm looking at the cell cycle, this is the order in which things happen. Just curious, do you remember, if we're looking at interphase, which is G1, S, and G2, anybody remember which one of those DNA is replicated or synthesized in? I hear a couple guesses. What do you think? S, right? DNA is replicated or synthesized in S. S and synthesized beginning with the same letter. And then here you're just matching things to your diagram. So if a cell spends 90% of its cell life in interphase, probably the biggest arrow that indicates the biggest portion of this diagram is going to be interphase. So interphase is A here. See if I can make this a little bit smaller so we're not scrolling so much. Tristan, how's your Chromebook holding up? Tristan, how's your Chromebook holding up? Is it almost dead? Oh, did you borrow somebody's charger? Oh, okay.
I was almost at before.
Who asked me for a charger? Oh. Zach, how's your Chromebook holding up? Is it dead? I'm sorry. I'll run back there and get it. I just didn't have enough time to stop. Like it wasn't plugged in all the way or something? Is your charger at home? I was gonna say, you could test it out when you get home and see if it lights up when you plug it in. I'm sorry, I didn't forget about whoever asked, I just hadn't had time to get back here. So if we match the following stages, we got A was interphase. Let's look at B, C, and D, because these are those three stages we just talked about that are part of interphase. So what's the part where cells just kind of growing and things are happening? It's the very first, number 1 of interphase. That'd be G1, that's easy. What kind of happens randomly here in the middle where DNA gets replicated or synthesized? S, remember S and synthesized. So that means that the last leftover G in interphase is going to be what? G, G2. So those are listed. And then we know that the very last thing that happens is going to be cell division. And E is showing you mitosis where we got the P mapped, those phases indicated there. So this is what your answer should look like. And we'll start moving faster, so we have a little bit of time left. This is true or false. As an infant grows into adult, the number of cells increase, but the size of cells remain constant. Is that true or false? Izzy, when you grew from a baby, did you just get giant cells and that's how you got so tall, or did you just get more cells? Probably more, right? You don't have giant cells sitting up there making bigger. So is this statement going to be true or false? So that answer's true. It'd be weird if your cells didn't get bigger. Cells divide at different rates. Which of the types below would divide at the fastest rate? So we know that certain cells divide faster just because of the kind of cell they are. They probably get hit up a lot, need a lot of repair. They probably are damaged or in a position where they get damaged, or they just need a faster life cycle so that they can grow more. Which do you think qualify for that? Which of the look like the cells that see more action where they're gonna need to be repaired more? Did you just say it? That's a good guess because your muscles do see a lot of action, right? And they're constantly moving. The thing about muscles though is they're not gonna be damaged a lot unless of course, well, don't let Annika tell you about her muscle damage story. But your muscle actually has, cells have a lifespan of about 25 years. Or I might be thinking of bone, about 16 years for muscles. So they have a pretty long life cycle. So they're actually, even though you're thinking correctly about that, they're not the ones that see the most action in terms of getting damaged a lot. What are cells that you see that might come into contact, Caden, with like, a lot of food, a lot of acids, a lot of things happening as they're like, constantly, yeah. Cells that line the stomach and the intestine. They're probably gonna divide at a different rate, a faster rate, because they're constantly in need of repair. They're constantly being used and coming into contact with other things. Clayton, is that what you were gonna say too? Yeah. So I like the way you were thinking, but now you know that probably a better choice would be to think, well, which of these cells is really going to come into contact with things that's going to do some damage that needs to be repaired. Okay, 14. In which of the cases below would a cell undergo apoptosis? Do you remember what apoptosis is? Remember what I told you to think about when you see that word, the pop part? I don't know if it's for better or worse, but I always think of like a cell, like a balloon, and it pops. And then what would happen to a cell if it popped? It's gonna die, right? So what do you think would happen that would cause a cell to die? Which of those? A brand new cell is formed? There's nothing about cell death in there, I don't think. A cell moves from G2 into mitosis. That's just going from interphase into cell division. It doesn't sound like a cell would need to die to do that, right? A cell reaches its full size, maybe. A checkpoint determines that a cell is missing organelles or has damaged DNA. In which of these cases, in the two we've got left, does it sound more likely that the cell's gonna need to die? What do you think, Izzy? Yeah, if there's something wrong with it, then what's going to happen is that cell is going to be killed and it's going to be taken away by helper cells, because we do not want a cell with incorrect genetic information or missing organelles. We don't want that cell to divide and make more wrong cells. We want to ensure that we get rid of that cell so that all of the cells that are currently dividing have the right DNA, the exact copy of organelles, and that nothing's wrong with them. Okay, number 15. Getting there. Multicellular organisms use mitosis for growth, development, and what else? Repair, apoptosis, which is cell death, interphase, or reproduction. What do we use mitosis for? Growth, development. We talked about this with the stomach cells. We need it for what? Do we need it for repair? Do we need it to kill cells? Do we need mitosis for interphase? I don't even know if that makes sense. Or do we need mitosis for reproduction, like in order to make new people? Cooper, what do you think? Say it again? Repairing, yeah. Because mitosis is cell division of our body cells, and so we need to make more of those cells when we grow, or if things are damaged to repair those cells. What time is our escape time is not until 21, so we'll be able to finish this out. Not as far as I wanted to get, but close enough. Is that it? Why was I thinking there were 18? There are only 15, right? Yeah. Wasn't it? Okay. There were? Come on, Zach. I could have sworn there were 18 too. Miss Wilmer?
No, it was only 15.
Did we cut some out? Maybe I was thinking, okay.
The original was like 18 or 20, but we caught a couple questions.
Apparently Zach and I were in the same multiverse, the rest of you were in a different one, because I remember 18 too. Cooper, what you got?
If cells usually go mitosis, like 10% of their lifetime, or most cells usually like divide or repair
They
every
do,
16 years. Does that mean like from 14 and a half to 16, you like see your cells?
oh, well, you know, if you took a sample of muscle cells, remember how in the onion root tip cell, we saw cells going through mitosis, but not many, right? So if you took a sample of muscle cells, depending on where those cells were in their cell cycle, you probably would have a real hard time finding any that were going through mitosis. The thing is, the faster a cell goes through its cell cycle, the more likely it is we're gonna see cells in mitosis. And because a root grows so quickly, we had a better shot of seeing them. A muscle cell, we could take samples all day and never run into a cell going through mitosis. Make sure you submit your CFA again for me, so that I can make sure that we're all square. And you know what, tomorrow we'll correct our CER and then start taking a few notes. Carson, this is for you, by the way. Zach, my apologies that I never